Yeah, so the topic that we have done for our homework assignment is GitHub Archive Analytics. The topic that we have chosen is GitHub Archives. So GitHub exposes archives or activity of all the public open source organizations and their public repositories. We have decided to make an analysis over the data that they are exposing for TensorFlow, Postgres, and MariaDB, and show some insights onto it. So the purpose of why we are doing it is maybe for open source students who are trying to get into open source, or somebody who's aspiring to work in that domain, can, like, according to the company, they can see the open topics or open issues they want to contribute to and then start contributing. So that was the important point why we chose this data set. So we're doing this using different technologies, database technologies. We have modeled, one of the technologies was graph database. So taking the data snapshot, which looks in the form of this. So the archive data exposes issue events, which is a commit event or opening an issue to a repository, and what that repository is belonging to, which organization, and the actor user who is creating the issues. That is the data snapshot, and we have modeled it in this way, where user creates an issue event. That issue event belongs to an issue, and it could be of type open, reopen, and all of the closed and all of that. Issue will also have a label because it could be a bug, it could be an enhancement feature, etc. And in turn, repos have multiple issues. These repos belong to the organization. So this is how we have coded it. This is the data in short. Mrinali will be taking over the workflow.
Yeah. So for this of a homework, we have followed like the below workflow that we are looking at. So we went through multiple data sets and finalized our data that we have collected from the GitHub archives. And then later on, we model that particular data using Cassandra, Neo4j, and MongoDB. Using that, we deployed these three Cassandra, using that Cassandra, Neo4j, and MongoDB using our Docker. So basically, using Docker, we have created couple of containers and you for our databases. And basically, we using that containers, we can like run our instances on our host machines. And then we have also performed our analysis using a simple like few couple of queries using MongoDB and Neo4j. And at last, as you can see, we have also performed few visualizations using the Mongo charts. Over to Kanchan now to explain sharding.
So for this homework, we created multiple containers where we are hosting Cassandra database, MongoDB databases, and Jupyter Notebook. The reason for using Docker and containerization is that most of these technologies are for distributed databases, and those doesn't work well with the non-unique based operating systems. So here we created multiple networks. First network we created for a MongoDB, another for Cassandra, and another one for a Jupyter node. In each network, we created multiple respective containers. Like in Cassandra, we created multiple containers, and in Mongo, we created multiple containers. For Mongo, we created 3 server configuration, and individual server has a multiple shards in it and some replicas of the data in it. And also same done for a Cassandra, and then for same is done for a Jupyter. Just that for a Jupyter, there are no multiple shards or replication set. It's just a one container. And for all of this, we mounted on a physical file system so that we can access this data later on. And apart from that, we given it as an external port so they can communicate with each other. This way, we applied microservice architecture to this. Over to Prasad.
Yeah. So after analyzing the data, after doing the sharding, after storing the data in the database, the most important thing comes, that is how to get the data which we have stored. So for that, we have written some queries like in the Neo4j, in the MongoDB, which will help you to analyze the data as per your requirement. For example, in the further screenshots, as you can see here, as the contributors in 2023. So this data is about the organization and the user. So the the total contribution of the issues by a particular organization or a user, you can get the data out, with the queries in the MongoDB. Also in the Neo4j, as you can see, next slide. As in the next slide, can you please, yeah. As you can see, here are the relationship between the relationship being created with the which is an actor, that is your user acts on the issue event and gets the data of all the contributors by their user login and the number of events they have performed. Similarly, we have also got the most active repositories in the organization. Total, for example, there is an organization which has different number of repositories. So, which are the most which are the most active repository actively used and are performing different type of issue events and creating an issue events and performing an issues with the help of storing the issues. So as you can see here that the TensorFlow TFJS has the number of issue events being created around 770. Similarly for TensorFlow model. So similarly for TensorFlow model. Going further, this is the query for the number of open issues and which are unresolved, and the closed issues which are already resolved and been cleared from the repository. So these are the numbers. So these are the simple way in which you can get the queries. You can run the queries and get the data on the Neo4j and MongoDB. Further, using the MongoDB charts, we have visualized some varieties of contribution by open source and user contribution to open source community and issue states by organization, as you can see here. So yeah, this is what we have performed till now. Yeah, thank you.
Yeah, I think अच्छा था ये वाला अपना.
4.5
You can
minutes
submit
पहला
this
वाला
also.
हुआ, उसके बाद मैंने अभी
2.5.
स्टॉप वॉच लगाया 2.5.
And I think 7 minutes हो गया ना total, 7-8 minutes.
I
That's
think
fine.
this is fine.
Yeah, this is fine. ये
You
अच्छा
can
था अपना.
upload this video also.
Yeah.
अब ये कहाँ जाएगा जूम का?
Captures में
देख
होगा.
लेते.
Desktop. अब ये हो गया ना?
Call में
Hmm.
I will just stop sharing screen.